Hi and welcome to the first video in the C5 chemical changes topic. So this video has three aims. The first aim is to recap how to predict ion charge. So this came up in the C3 structure and bonding topic, and it's a skill that will come up again and again throughout C5. So I thought I'd start by recapping how to do that. The second one is another recap of how ionic compounds form. So we're going to look at what actually happens to create an ionic compound. And then the third aim of this video is to go through new information on metal oxides, oxidation, and reduction. So let's start with how to predict ion charge. And I'm going to start by looking at metals and the positive ions that they form. So metal atoms become positive ions because they have lost electrons. And what we've got there, because of that loss of electrons, is an imbalance of charges. Okay, so what that means is they have more protons, which are positively charged, than they do electrons, which are negatively charged. And so because of that, they end up with a positive charge overall, a positive ion. So if you have something that is a 1 plus ion, it's lost one electron. It has one extra proton. And we can work this out in two different ways. The first one actually uses the periodic table. So you can use this in an exam to help you out. And what happens is this. If you look at the group number for the metals on the periodic table, the group number is the same as the number of electrons lost, which means it's actually the same as the positive charge on the ion. So if you have a group 1, you will have a plus 1. If you have a group 3, you will have a plus 3, and so on and so on. The second method that we can use for working out the charge of a metal ion is using Roman numerals. Okay, so a lot of the time you will see a chemical and it will be written something like this. So it might be copper to oxide. That there is your Roman numeral, and that Roman numeral actually tells you the charge on the positive ion. So if you have a 1, it's a 1 plus. If you have a 4, it's a 4 plus. In this one, it's a 2. So you have a 2 plus charge on your copper. So this chemical will be made of Cu2 pluses and O2 minus ions. So we can use both of these methods here to help us work out the charge on an ion. Okay, so the second part of this is to look at your non-metals, which are your negative ions. Okay, so if we think about this, your negative ions again are caused by an imbalance in charges, except this time around what we have is we have more electrons, which like I said before are negative, than protons. They've gained extra electrons, and so now there are more negatives than there are positives. So if we look at this, a negative ion would have gained a 1 electron. If we have a 2 negative ion, it would have gained 2 electrons. And again, we have two ways of determining the charge on our non-metal ion. The first one, just like before, uses your periodic table and a little bit of maths. So we know that 8 electrons gives a full outer shell at GCSE. So you can work out the number of electrons that an atom can gain by taking your group number away from 8. So for example, if you have a group 6, you would do 8 minus 6, which tells you that it's a 2. So it can gain 2 electrons, so it's a 2 minus ion. If you have group 7, it's 8 minus 7, which would be 1 electron, so it would give you a 1 minus ion. The other way we can do this is to look at a salt. So when acids react, they produce salts. Salts have specific formula. So this formula for sulfuric acid is H2SO4, and the salt is SO4. We can work out what charge that salt will have based on how many hydrogens it has. So this has 2 hydrogens. That means that it's actually going to lose 2 positive charges. So the charge on this ion will be 2 negative because it's lost 2 positives. It's got 2 extra negatives. So that's how we would work out our negative ion charges. Okay, guys, so I'm going to move on to the next recap and look at how ionic compounds form. Now, again, you would have learnt about this in our C3 structure and bonding topic. So when we talk about ionic compounds, we're talking about reactions between metals and non-metals. And the reason they become ionic is this bit here, because they transfer electrons and we get that imbalance of charges. So a typical question in an exam is a 4-marker which asks you to explain how a given chemical comes about. So it might be magnesium oxide or it could be sodium fluoride. And the way to talk about that is to look at this here. So what you need to do is you need to tell them about how the metal atom becomes an ion and how the non-metal atom becomes an ion and then what happens between them. So if we look carefully, the metal atoms transfer electrons to the non-metal atoms. The metal atoms become positive and the non-metal atoms become negative. Electrostatic forces of attraction between the oppositely charged ions hold them together in the compound. So if I give you an example of one of our ionic compounds, this is NaCl. What happens is sodium transfers 1 electron. And because of that, it becomes an Na plus ion, a 1 plus. When that electron is removed, it goes over to our chlorine and it gains that 1 electron. And our chlorine becomes a Cl minus. And what actually happens then is if this is our Na and this is our Cl, they attract together. And this attraction is our electrostatic force. And that's what actually creates the bond. So that's a typical question that comes up in an exam. Okay, so moving on to new content, we're going to look at metals. And the first thing that you guys need to know is this definition right here. So what is a metal ore? So metal ores are rocks which it's economically viable to extract the metal from. What we mean by economically viable is that we can make a profit. The whole point of doing anything in chemistry like this is to make money from our process. So we would look at a rock, and if there's a high percentage of metal in there, we would break it down and cause reactions to get the metal out and purify it so we can sell it on. If there isn't a high enough percentage of metal in there, we wouldn't bother doing that. It's not worth our while. So most metal ores are actually made from metal oxides. These are the most common ones found out there. And what has happened is that our metal has reacted with oxygen. And we can say that that metal has been oxidized. And this is a key term that we use quite often in chemistry. It's the term oxidation. And oxidation has 2 meanings, which I'm going to go through in this video. The first meaning is to gain oxygen, and the second meaning is to lose electrons. I'm going to talk to you about that in a couple of minutes' time. So if we look at our metal oxides, you will see that I started with ionic compounds because they are actually ionic compounds. They're made of a metal and a non-metal, because that's what oxygen is. And so this is where all of those skills come in from previously. So what we have happening in this reaction is we have our metal and our oxygen coming together to create our metal oxide. Now this symbol right here is what we use as a standard symbol, and it just means any metal. Because capital M isn't actually a symbol on the periodic table, we can use it. So if we're saying a metal reacts with oxygen, we can give it the symbol M. This is the standard symbol for oxygen. Oxygen is diatomic. It goes around in pairs to become more stable. And then this here is the symbol for a metal oxide. And what we have is we have M with a subcase N. And that subcase N stands for any number. And the reason for that is because what I'm going to teach you next will show you that The number of metal ions in the oxide will change depending on the charge of that ion. So it will depend on how many positives it actually is. And the same for our O with the subcase N. That N means any number as well. And again, that would be because we have to change the number of oxygens in our metal oxide to cancel out the charges on the metal. Remember, when we have an ionic compound, whatever negative charge we have has to equal the positive charge, because overall the compound itself has no charge. Okay, so let's have a look at our metal oxides in a little bit more detail. So the first thing I'm going to go through is the charge on an oxygen ion. Oxygen ions are always -2. They have gained 2 electrons. That never changes. So you can learn that and just remember it for the exams and use it in the questions that you're asked. Metal ion charges depend on the metal. So what that means is if we have a group 1, we'll have a +1. If we have a group 2, we'll have a +2. If we have a group 3, we'll have a +3, and so on and so on. And of course, we can also use our Roman numerals to do this. But the thing to remember through all of this is this bit right here. The total charges of the ions must cancel out. So what we mean by that is positives have to equal negatives in the compound. So I've got some examples to show you right here. So if we look, we've got lithium oxide. Now the formula for lithium oxide is Li2O. And the reason for that is lithium is group 1. So it's a 1+ charge. Oxygen, as we know, is already a 2- charge. So in order to cancel out the 2-, we have to have 2 times the lithium. So the lithium gets a small 2 written next to it. If we look at magnesium oxide, that is MgO. Magnesium is a 2+ charge, oxygen is a 2-. So 1 magnesium will cancel out 1 oxygen. And then if we look at aluminium oxide, we have Al2O3. Aluminium is in group 3, so it has a 3+ charge. Oxygen is a 2-. So we find a number that they both have in common. And the number that these two have in common is 6. So if we do 2 times aluminium, it would be 2 times 3+, which would give us 6+. And if we do 3 times 2-, that would also give us 6-, which would cancel out. And so that would give us the formula Al2O3. Okay, so 2 keywords that we need to know. One I've already mentioned is oxidation and reduction. Now, oxidation and reduction have 2 meanings in chemistry. We can refer to oxidation in terms of the movement of oxygen, so I'll just cover that, or we can talk to you about it in terms of the movement of electrons. So I'm going to start with the slightly easier meaning for these 2 terms and then move on to the more complicated versions. So if we look at what we've got down here, oxidation and reduction in terms of oxygen movement. So when a substance reacts with oxygen, we can see it has been oxidized and oxidation has happened. When we're talking about this, what we actually mean is it's gained oxygen. Oxygen has been added. So if you look at this reaction right here, magnesium plus oxygen makes magnesium oxide. We are physically adding oxygen to it. If we talk about reduction in terms of oxygen movement, if a reaction removes oxygen from a substance, we can say it has been reduced or reduction has happened. And so if I was to write this on this bit, we say that it's lost oxygen. And so you can see I've used the same reaction, but in the opposite for our example. If we've got magnesium oxide and we break that down into magnesium and oxygen, we've actually removed the oxygen from the magnesium oxide. So it has been reduced. If we go into the more complicated version of oxidation and reduction, and for those of you doing triple chemistry, they are going to refer to it more often than not in this version. We need to talk about electrons and the movement of electrons. So we can determine if something has been oxidized or reduced by looking at how electrons have moved. And the reason we use this is because we can actually use oxidation and reduction for any reaction between a metal and a non-metal. If we're talking about oxidation and reduction in terms of oxygen, it only works with metals and oxygen or metal oxides. This can be used for any chemical. So if we look at what we've got here, oxidation is the loss of electrons by a substance. Reduction is the gain of electrons by a substance. So how do we determine which species is oxidized and which is reduced? So when magnesium and oxygen react, they undergo what we call an redox reaction. And it's called redox because what we've got is we've got reduction and we've got oxidation happening at the same time. So if we look at our equation here, 2Mg plus O2 makes 2MgO. Magnesium plus oxygen makes magnesium oxide. Magnesium oxide is ionic. It's made of Mg2 plus and O2 minus ions. So if we look at this, this here is called a half equation. And what it shows, and I'm going to write an explanation of this, is half equations are used to show what happens to electrons in the actual reaction. It lets us track the electrons through the reaction. So if you look at this, magnesium is oxidized, and our definition of oxidation was that it loses electrons. So we start with a magnesium atom, and we end with a magnesium ion, a 2 plus. So if we've got two magnesiums and they both become 2 plus ions, they have lost a total of 4 electrons. So we write it as 2Mg2 plus 4E minus. The plus basically means that the electrons are also there, but they're no longer attached to the magnesium. Each magnesium's lost 2 electrons. If we look at our oxygen, oxygen is reduced, and our definition of reduction is that it gains electrons. So if we look at our example, we've got O2, that should be a small 2, sorry about that, guys, and we are adding 4 minus to it, and it comes out at 2O2 minus. So the electrons from here have actually gone over here and bonded to our oxygen, creating oxygen ions. Each oxygen atom has gained 2 electrons, and that's a key thing to actually remember about our half equations. The electrons in each half equation must be the same. So if you end up with 2 in one and 4 in the other, you've got a problem and you need to multiply them up and balance those equations. As you go through GCSE chemistry, we'll actually teach you how to balance equations using half equations. Okay, guys. So let's have a look at how you can remember what's going on in oxidation and reduction. So this here is an acronym that comes up often in chemistry, and it's an easy way of remembering oxidation and reduction in terms of electron movement. And it's called Oilrig. And what we use it to symbolize is oxidation is loss of electrons, reduction is gain of electrons. So you might hear me referring to it in lessons or in other videos as Oilrig. Oxidation is loss of electrons, reduction is gain of electrons. And this only really works when we're talking about the movement of those electrons. It doesn't work if we're just talking about oxidation in terms of oxygen movement. So what we have to remember here is something is losing the electrons and something is gaining the electrons. Now, I've already mentioned the last key term that I'm going to talk to you guys about in this video once before, and that's redox reactions. And redox reactions happen when we have oxidation and reduction taking place together. And redox reactions are most often found in reactions that form ionic compounds. Because the metal will be donating electrons to the non-metal. I'm going to show you an example of a reaction that creates an ionic compound that involves both oxidation and reduction, so it's a redox reaction, but isn't between a metal and oxygen. So if you look at this here, this is magnesium fluoride. This is an ionic compound. So what actually happens is our magnesium will become an Mg2 plus ion. And when it becomes an Mg2 plus ion, it has lost 2 electrons. So this has been oxidized. It has undergone oxidation because it has lost electrons. And I'm just going to put that here for you guys. If we look at our, I'm going to change colour so this sticks with the colour scheme that I've already got, change to blue. If we look at our fluorine, fluorine exists as pairs, and what happens to fluorine is a non-metal, so it's going to gain the 2 electrons that magnesium lost, and it's going to become 2F minus, and this is reduced because it has gained electrons. Okay, guys, and so that's an example of a redox reaction which doesn't involve oxygen. There is still the movement of electrons, and if you look, those electrons on both sides of these equations are exactly the same as each other. And that's what you need to remember. Reduction and oxidation in terms of electrons can happen between any metal and non-metal forming an ionic compound, and they're most often called redox reactions. And you need to remember that these electrons that are gained and lost have to equal each other. So what you might have to do is you might have to multiply your half equations in order to do that. Okay, guys, I will be back soon with another lesson on C5 where we will go through the reactivity series of metals.